Well, if that whole thing is 90 degrees, what do we know if we have tick marks on a chord? What does that mean about the arcs? Yeah. They're the same. So these marks on the chords might as well be on the arcs. And so each of those arcs must be the same measure, and they both have to be 45 degrees. And ask what's CD? Well, CD is 45 degrees. Questions on the bell work? All right, I do want to quickly go over really quick. Hey, don't forget about, there's an answer key online, right? If you're not sure how to do something, it's not wrong to look at the answer key for a guide. It's wrong if you're copying it. If you're straight up just copying it down word for word, not knowing what's going on. Why I'm saying that is, if you ever get stuck, just look at the answer key for a hint. I try to draw all my pictures that I do. I try to pull out all the triangles. I try to point to everything and how I solved it. So I put all that work in there, not for people that have it correct just to check their answers. This is for people, if you're stuck, go online, look at it, and get hints on how to do stuff. We shouldn't have sheets that are just blank, because I didn't know how to do it. All right, that means we didn't understand the lesson or something else, and we need to meet with me. So that being said, what questions do we have from this homework, though? Yeah, Joaquin. Number 28 says X, Y, and Z are points on a circle P such that X, Y, Z is an equilateral triangle. If the radius of circle P is 6, what is the perimeter of triangle X, Y, Z? So let's go ahead and pull this guy up real quick. So this one is probably the most challenging one on there, which it makes sense why it's the last one. But the big thing is, we first have to draw 3 points. I guess I should have labeled these as X, Y, and Z, or Z. So let's go ahead and label this X, Y, and Z. And kind of importantly, since it's an equilateral triangle, all the sides are the same length. And also, all of our angles aren't 30 degrees. They're 60 degrees. They're 60 degrees. Let's put our tick marks on everything. So really, if I ask for the perimeter, I'm asking for just one length. And then you multiply that length by 3. I'm just asking, what is one length? Multiply that by 3, and we have our perimeter. Then they give us more information. They say that something about the radius. I don't have it in front of me. And the radius of circle P is going to be 6. So we're going to note the only place that really makes sense to draw a radius is straight up or at one of these points here. Because anywhere else I draw a radius, let's just try to draw one somewhere else, doesn't really help you anywhere. Like it doesn't, I don't know where that's connecting with the shape there. So okay, so we have that. So I'm going to draw that 6 here. Now, we have to know a specific property, i.e. if I draw a line from P to this line, forming my own right angle. Like I said on the bell work, a right angle tells me it's going to bisect that segment in half. So I drew this line creating a right angle, but that right angle automatically means that I'm bisecting this side here. That's what a right angle meeting up with the center of a circle does. So just picture this as a chord with a right angle and a line going to the center. We have the property that says that it would then bisect. Well, that means I'm cutting this in half, giving me a 30-degree angle here, which means this has to be a 30, 60, 90 triangle where I know one of the sides. So I went ahead and pulled that out. I pulled out my 30, 60, 90. I said my 2s equals 6, so my s would equal 3. So that would make this side 3 square root of 3. Well, 3 square root of 3 plus 3 square root of 3 would be 6 square root of 3 times 3 would be our 18 square root of 3. Does that make a little more sense? That one I could see that drawing being a little confusing because where did I come up with this? But this is predicated on you knowing this. That if I draw a line from the center to a chord and I put a right angle there, it automatically cuts that chord in half. All right, other questions? Yeah.
26 26.
26 says... 26 says in circle S, chord at a GF subtends a 120-degree arc. So that means we have to draw a chord and a 120-degree arc on there. Then it says if SG is 10, what is the length of GF? Well, SG is a radius. So go through the thought process of how you draw this. So first I would have drawn this. Then I would have drawn this. Then anytime you have an arc numbered, we're going to draw an angle to it most of the time. So I'm going to go, okay, I got part of a triangle here. Let's finish that off here, forming a central angle. And that central angle meets up with 120, so that angle right there must be 120. Okay? And then we would draw this line up to create our right triangle. Creating a 60-60, that'd be a 60-30-90 with a 10 as the hypotenuse. Okay?
Yeah.
All right, other questions? Kate? 27, once again, I'm just going to take a picture of my answer key. So we have in circle T a diameter BC is perpendicular to chord MN. So we would draw a chord BC going across. It says it's a diameter, so we draw it all the way across the center. And then we're going to draw an MN somewhere, and we're going to put a 90-degree angle on there. Now the hard thing about this one is they do tell you that BN, the arc BN, is 150. Now, my hint I gave to Jacob is we're always going to draw some sort of angle to that. So when they tell you that BN is 150, we're either going to draw a central angle or an inscribed angle to help us figure out something with angles. So as soon as they see that 150, what I'm already picturing is when I see 150, I immediately picture that angle. Okay? The only other angle we could picture with that 150 is maybe this one. Because I could half it, and I could say that this is 75 degrees. But the problem is that doesn't get me too far because I don't know any other angles. So, Kate, once again, as soon as I tell you an arc to draw, so I have that 150, you're going to picture one of two things. You're either going to picture a central angle, draw that central angle that subtends it. If that doesn't work, then try to draw an inscribed angle, because those are the only two that we know. One equals it and one is half it. If I don't have either one of those, I can't go any further. Okay? So on all these drawings, if I give you an arc, you should either have a central angle or an inscribed angle to finish that problem. You got what? I'm sorry?
S equals 8.
So we have S equals 8. Oh, you have NE equals 8, right? Are you talking about this equaling 8?
Yeah.
Okay, and that's 8.
Yeah.
Okay, and then what are we looking for? We're looking for the diameter, right? Okay, so really that S equaling 8. Yeah, so that equals 8. So we have NE equals 8. We'd also want to find I guess TN. TN's more important. So what I'm looking for is that length there. That purple length I have drawn right there. That's the length I actually care about, because that's my radius. And my radius is half my diameter's length. So yeah, it's good to have S equals 8, but now I want to get my TN. My TN is 2S, so this is actually going to be 16. So by that 60, 30, 90 triangle, this would be 16. And since that's a radius, my diameter is made up of 2 radii. I just have to have 16 times 2. That's why I have my 2 times radius right there. So it's less about finding actually BC. It's more about understanding that a diameter is 2 radii. That if I find 1 radius, I actually have my diameter. Just like if I ask you to find like a specific length. So maybe I'm asking you to find TN, but all you can find is length BC. You would take BC's length divided by 2, and that would be the same length of that radius. We just got to picture that we have radii and we have diameters that meet up, that they have equal lengths, or I guess the diameter is twice as big. All right, other last-minute questions. Okay, good. We need to move on. All right, tangent theorems. So we had a bunch of theorems yesterday, or things. We're going to talk about 2 with a tangent line. Just a reminder, a tangent line is one that intersects the circle in only one place. Only one place. Well, this one says a line is perpendicular to the radius or diameter if the circle, if and only if the line is a tangent line. What that means to you is if you ever see a tangent line, and then you see a line that goes to the center of the circle, either a radius or a diameter, so this could be extended down. You got to look out for both a radius and a diameter. My advice is if it's a line going through the center of the circle. If I have a line going through the center of the circle that meets up with the point of a tangent line, that angle is automatically 90 degrees. Automatically. So a tangent line meeting with a line that goes to the center of the circle is 90 degrees. Now, I want to point something out here. If you see a line that's connected to a tangent line, and you see this 90-degree angle, that means this line had to have gone through the center of the circle. So let me just show you what I kind of mean. Like, let's pretend I don't have that C there. Let's say I don't have that C there, and I extended this out, and all you saw was this. You would then know that this is a diameter. So because of the 90 degrees and it meeting up here, you would then know that is a diameter. All right, so it goes both directions. Tangent line, diameter equals 90 degrees. That's going to be important. Next thing, 2 segments drawn from the same circle that intersect outside the circle are congruent if and only if they both are tangent to the circle. I call this the hat theorem. I didn't really turn it to be like a hat, but if you kind of turn this on its side, it forms a little hat. And the big thing is, do you notice how both of these are tangent lines? These are both tangent lines because they hit the circle in one place. Well, if you see 2 lines that hit the circle in one place and meet up out here, these lengths are going to be the same. BD is the same as AB. I added more to the drawing because, as a reminder, if you have a tangent to a circle, if you draw a line that goes to the circle from that other one, it equals 90 degrees. But the big thing is, if you kind of see that hat, whether it's sideways, upside down, or not, know that these segments are congruent. So tangent lines that meet outside the circle have congruent segments built into them. But once again, I brought in the one from before, that if it's a tangent line, we can connect a line to the center, and that's automatically 90 degrees. All right, a couple examples. The first one, find B. What bits of information do I know, knowing that those are tangent lines? Daniel.
That the angles, that the lines that make up angle 36 are congruent.
Yeah, they're congruent. So that's one thing we know. We know that I could put a line there and there. That's kind of our hat theorem, or I guess kind of looks like a duck theorem in that case. What else do we know based upon that drawing? Yeah. That we have 90-degree angles, right? So we have a 90-degree angle here. That doesn't look like a 90 degree. That looks more like a 90 degree. That looks like a 90 degree because we do have, those are both our theorems all in one. One is if tangent lines meet out the circle, they have congruent segments. The other one says if you have tangent lines and a line going through the center, then they create 90 degrees. Probably use that 90-degree one to solve for 36, right? Because how many degrees are in a four-sided shape? 360. There are 360 degrees inside of this shape. So if there's 360 degrees, and I eliminate 90 and 90, that's 180. That only leaves us 180 left to split between these two. So we just have to do 180 minus 36, which is going to be 144. Did I do that right? So B is going to equal 144 degrees. Is this line going to the center of the circle? No. Thank you for shaking your head after saying yes. So do we have any 90-degree angles? No. Has to go through the center of the circle for us to do the 90 degrees. So the only thing we can use is the fact that we have tangent lines that meet outside the circle. So we can put our tick marks there. How does that help us solve the rest of it? I put my tick marks down. How do I solve the rest of it? No?
You can put 48 degrees on the upper angle.
Yeah, we can put 48 degrees up there. So what's D then? What's D equal? If I have that 48, 48, what would be left over for that? Daniel? 84 degrees. All right. Did I miss anything? 250. No, that's about it. That is the end of our lesson. Be on the lookout for all of those particular shapes. It does get a little bit difficult around 9 through 12. 17. Do you all look at 17? Can I look at your 17, actually? Okay, I did. 17 is a challenge question. Remember, that doesn't mean I should just see it blank. I should see you tried it. If I just see it blank, then I can take points off because you didn't do anything. At least attempt 17. I put it as challenge because I don't want you staying awake till 1 o'clock tomorrow morning working on that one problem. It's a difficult problem, but I want you to at least draw pictures and at least conceptualize it. So when we go over tomorrow, you're like, oh, that's kind of what I was thinking, or nope, I was way off. So I want you to at least try it.